In this video, we will see the Python implementation of inserting a new node to singly linked list. Before watching this video, I suggest you watch the last video which explains the concept of inserting a new node to singly linked list. The link is given in description box. For the new node, we need the class node. Data and next pointer gets initialized through constructor when you create the object of the node. We will have one more class, linked list. In this class, we will define the operations which we want to perform on the linked list. Before defining the operations, we will have a constructor which will initialize the head. Here, head is initialized to none. We will create an object of linked list and see. I'm running in debug mode for better understanding. You can see a linked list with head pointing to none is created as shown in figure. Now we will define the operations. First operation that we are going to define is append, that is inserting at the end of the node. Here the method append takes the current object and data. First thing is to create a new node. New equal to node of data. This creates an object of the class node with data initialized to data we passed and next pointer as none. We discussed in our last video, when you append, you need to consider two scenarios. First one is when there are no nodes in the linked list and the head will be pointing to none that time. So the first condition we need to check whether the head is pointing to none. So if head is none, then assign head equal to new. So head will point to the new node. Now the second scenario is when there are nodes in the linked list. That is else condition. Here first we need to define a pointer temp because we need to traverse till the end of the linked list. So temp equal to head. Now we need a while loop for traversing. So while temp.next. This loop will traverse till temp.next is none. Whenever temp.next is not none, temp equal to temp.next. That is temp will point to next node. When temp.next is none, the loop will exit. That is temp is pointing to the node which has next as none. That is the last node. Now we got the last node. Now the job is to link the last node and the new node. So temp is pointing to last node. So you just have to give temp.next equal to new. So this will link new node to the end of the linked list. Now we will define the operation to print the linked list. For printing, you need to traverse through the entire list. When there is traversing, we need a pointer and while loop. So first have a pointer temp which will point to first node. So temp equal to head. Now while temp, this loop will continue till temp is none. So temp will point to each node in the iteration and print the data of that particular node. This arrow is just for displaying purpose to show the link between the nodes. And end equal to quotes, this is just to print in the same line. After printing data, temp has to point to next node. So update temp equal to temp.next. Now we will execute and see. First I will append 28 and print the linked list. You can see we are able to insert the new node when head is none. That is when there are no nodes in the linked list. If I append 46, it got inserted at the end. Now 18 also got inserted at the end. Next operation is prepend, that is inserting at the beginning of the node. First create the new node. Now new node should point to the first node. Head has the address of the first node. So give new.next equal to head. Now new node is linked to the first node. Now point head to this new node because this new node is the first node now. So give head equal to new. Now we will execute and see. Here I have done the append operation already for the nodes 5, 2, 8, 6. So we have the linked list with nodes 5, 2, 8, 6. Now I give prepend 12. Here 12 got inserted at the beginning of the linked list. If I give 15, 15 is inserted at the beginning. Next we will see the operation insert at position. First create the new node. Now here we need to traverse to the particular position. So we need a pointer and while loop. So the pointer temp will point to the first node initially. We also need a variable count to check if we have reached the particular position. Initialize count equal to 0. We are taking the position from 0, so count also should be initialized to 0. Now while loop iterates till the count is less than position minus 1 because we need the pointer to the node before the position. For example, if we have to insert at position 2, we need to update the next pointer of node at position 1. So the loop will exit when the count reaches position minus 1. Till the temp pointer reaches the node at position minus 1, the temp pointer has to be updated to the next node, that is temp equal to temp.next, and the count should be incremented. Once the temp pointer reaches the node before the position, we insert the node. For that, give new.next equal to temp.next and temp.next equal to new. So this will insert the new node at the corresponding position. We will execute this method and see. I will pass 22 as the node data and position as 3. So 22 should be inserted at position 3. The linked list here we have 15, 12, 5, 2, 8 and 6. So at position 3 the node is 2. If we start from 0, the node at position 3 is 2. So 22 should be inserted between 5 and 2. After executing, you can see 22 is inserted between 5 and 2. We will insert one more node 4 at position 5. At position 5, the node is 8. So new node will be inserted between 2 and 8. You can see the node is inserted between 2 and 8. By this, I am concluding this video. Thank you for watching.